Now next up, we have fatty acid metabolism. Now do you happen to remember where fatty acid metabolism takes place? There you go. Fatty acid synthesis is going to take place in the cytoplasm, and fatty acid degradation, or breakdown, is going to take place within the mitochondria. Now we're going to start this pathway with fatty acid synthesis, or how fatty acids are made. And as you can see here, citrate is the substrate or the building block of fatty acid synthesis. Now the first step in fatty acid synthesis is to transport this citrate from the mitochondrial matrix into the cytoplasm via the citrate shuttle. Now during this process, citrate is acted on by ATP citrate lyase, as you can see here, and acetyl-CoA is produced. Also during this process, NADPH is created. Now fatty acid metabolism takes place primarily in 3 locations. It occurs a lot in the liver, adipose tissue, as well as lactating mammary glands. Now once in the cytoplasm, the 2-carbon acetyl-CoA is carboxylated to a 3-carbon malonyl-CoA by acetyl-CoA carboxylase, as you can see here. And like most carboxylation reactions, biotin is used as a cofactor here. And this also happens to be the rate-limiting step of fatty acid synthesis, and therefore heavily regulated. Now in our next step here, fatty acid synthase is used to add 2 carbon units from malonyl-CoA to a growing fatty acid chain until it reaches its full length. And this step actually requires NADPH, which was conveniently produced from the citrate shuttle. Now after this process repeats itself, palmate, which is a 16-carbon fatty acid chain, is created. And from here, this chain can be further elongated or desaturated or converted into acylglycerol. Now with all that, we're going to wrap up fatty acid synthesis. So now let's look at fatty acid breakdown or degradation. Now once again, remember that this takes place within the mitochondria. And this process is actually also known as beta oxidation. Now in our first step here, our fatty acid chain plus coenzyme A get converted into the 2-carbon unit fatty acyl-CoA by the enzyme fatty acyl-CoA synthetase. Now these acyl-CoA molecules are transported into the mitochondria using the carnitine shuttle, which ends up being inhibited by a buildup of malonyl-CoA. Now once we've successfully moved our fatty acyl-CoA into the mitochondria via the carnitine shuttle, we encounter the enzyme acyl-CoA dehydrogenase. This enzyme converts our fatty acyl-CoAs into acetyl-CoA by making a double bond in the acyl-CoA, which is required for beta oxidation. Now as a result, these acetyl-CoA molecules can enter the TCA cycle to be used directly as energy, or they can be used to make ketone bodies. Now if all else fails, just remember on test day that the citrate shuttle is involved in fatty acid synthesis, and the carnitine shuttle is involved in fatty acid carnage or breakdown. Now when everything works correctly, our fatty acyl-CoAs use the carnitine shuttle to enter the mitochondria. But what would happen if the carnitine shuttle wasn't working correctly? Now in patients with systemic primary carnitine deficiency, there's an inherited defect in the carnitine shuttle. And this prevents our long-chain fatty acids from entering the mitochondria, which is required for long-chain fatty acid breakdown. These patients usually present with generalized weakness, hypotonia, as well as hypoketotic hypoglycemia. And why do you think they would be hypoketotic? Well, during times of hypoglycemia, our body turns to fatty reserves for energy. And if our carnitine shuttle isn't working, we get a toxic buildup of fatty acyl-CoA that gets stuck in the cytoplasm. Now this fatty acyl-CoA cannot be converted into ketone bodies or enter the TCA cycle. So all of this will lead to patients with systemic primary carnitine deficiency to be hypoketotic when they're hypoglycemic. Now the next disease association we want to discuss here is medium-chain acetyl-CoA dehydrogenase deficiency, which is an autosomal recessive disorder that leads to the buildup of 8 to 10 carbon fatty acyls in the blood. And our clinical presentation here is fairly similar to the one we just discussed, with hypoketotic hypoglycemia. These patients also have lethargy, seizures, vomiting, as well as liver dysfunction. So how do you think you treat patients with medium-chain acetyl-CoA dehydrogenase deficiency? Well, let's think about it. When do we actually undergo beta oxidation? Well, we use beta oxidation to break down fats when our glucose reserves are depleted. Now, if this process isn't working correctly, and we don't ever want it to take place, how do you think we treat that? There you go. Keep the body supplied with a constant source of glucose, and avoid fasting. Well, alright, that's going to wrap up fatty acid metabolism. See you in the next video.